Hello Year 12 and welcome to Purple Mountain Education. Today we're doing the 2025 HSC paper for Maths Extension 1. This is part 2, question 11, worth 15 marks. Question 11, part A, find the inverse function of the function f of x equals 1 minus 1 over x minus 2. Pause here to try yourself. Okay, so as a first step, I'm going to write the function as y equals 1 minus 1 over x minus 2. Now I'm going to swap x and y. X equals 1 minus 1 over y minus 2. I'm going to put 1 over y minus 2 on the left and 1 minus x on the right. I'm going to get the reciprocal of both sides. And then I'm going to get y equals 1 over 1 minus x plus 2. 11b, solve sine 2 theta minus sine theta equals 0 for theta between 0 and pi. Pause here to try yourself. Well, first of all, I'm going to replace that sine 2 theta with 2 sine theta cos theta. So 2 sine theta cos theta less sine theta equals 0. Now I can factorise on sine theta outside of 2 cos theta less 1. So by null factor theorem, it must be the case that either sine theta equals 0 or cos theta equals a half. I know that I'm only working in the first two quadrants. So theta is 0 or pi. I'm not going to consider 2 pi. And theta over here is pi on 3. And I'm not going to consider 5 pi on 3. So I double check that I've got the domain right, and I do. So the answers are 0, pi on 3, and pi. Question 11c, find the indefinite integral of sine 3x cos x dx. Pause here to try it yourself. Okay, so straight off the reference sheet, I'm going to use the fact that sine A cos B equals half of sine of the sum plus sine of the difference. And that will be helpful here. So my integral of sine 3x cos x dx can be rewritten as a half outside of sine of the sum plus sine of the difference dx. So I'm going to leave that half out there carefully with brackets. This is less a quarter cos 4x less a half cos 2x plus c, and just tidying that up a little, minus 1/8 cos 4x minus a quarter cos 2x plus c, and that's my answer. Question 11d. Sketch the graph of y equals a third inverse cos of 2x. Pause here to try yourself. So in general, I know what an inverse cos graph looks like. It's between 1 and minus 1 on the x-axis, not y, and it's up here at pi. It's at pi on 2. So it's that. Now that's the vibe of the basic one. I just need to note how I've adjusted it with these transformations. So I've got a vertical dilation factor of a third, and I've got a horizontal dilation factor of a half. So let me just adjust my axes in that way. So instead of going between 1 and minus 1 on the x-axis, it's now only negative a half to a half. And instead of going all the way up to pi, I'm going to call that only pi on 3, and this must be pi on 6. And it goes from here through there to there. And that's my graph of y equals a third inverse cos of 2x. Question 11e, for what value of m is the vector 1m parallel to the vector 2, 6? So the fact that they're parallel means there exists some scalar lambda such that when I put lambda in front of 1m, I'm going to get to 2, 6. So clearly that's telling me that lambda equals 2, and so it must be the case that m equals 3. Question 11f. The roots of 2x cubed plus 6x squared plus x less 1 equals 0 are alpha, beta, gamma. What is the value of this expression? Pause here to try yourself. So let's give this a go. Now what they're actually inviting us to find can be rewritten using a common denominator as alpha, beta, gamma, and then the numerator is gamma plus beta plus alpha. So the numerator is simply the sum of roots. The sum of roots is always going to be minus b on a, and in this case minus b on a equals minus 6 on 2 equals minus 3, and the product of roots is minus d on a, which is a half. So subbing those in, I get minus 3 over a half. I'm going to get minus 6, and that's my answer. Question 11g, evaluate cos squared 3x dx from pi on 6 up to pi on 3. Pause here to try yourself. Okay, so let's recall straight off the reference sheet. Right at the bottom there, I know that cos squared nx equals a half of 1 plus cos 2nx. So that seems useful. So in this case, cos squared 3x equals a half of 1 plus cos 2 times 3 is 6x. Okay, so my integral just turned into from pi on 6 to pi on 3 of 1 plus cos 6x dx, and that equals a half of x plus 1/6 sine 6x evaluated from pi on 6 up to pi on 3 equals a half pi on 3 plus a sixth of 6 times pi on 3 is 2 pi less pi on 6 plus 1/6 of sine pi. Now we know that sine of any multiple of pi is going to go to 0. That term goes to 0 and that term goes to 0. I'm just left with a half of pi on 3 less pi on 6. So inside the brackets there is pi on 6, and a half of that means my answer is pi on 12.